many chapters were?
4.
The test is 1, 2, 3, 4. The course 15. Means we're almost 25% finished. More than that when we do chapter 4 today.
5%? 2 weeks?
Okay, you had question 85 on page 95 to do for homework. And you were to find the mean, the median of the number of items, find the range, standard deviations, organize the number of items into a frequency distribution. Did this all happen? Let me make a wild guess and say I'm dubious. In fact, did anyone do it? Well, let me then. I don't know if I can say this is a good start. Manager of the local Walmart superstore is studying the number of items purchased by customers in the evening hours. Quantitative or qualitative?
Again?
The manager at Walmart is studying the number of items that people bought. Quantitative, and is it discrete or continuous?
Not continuous.
It's discrete. And which computer am I on?
Yeah.
Why is it flashing?
Push it again.
Getting ready?
Push it again. Alright, it'll start.
But this data is everything you should have done and everything new that I'm going to do. Okay? So first of all, it says find the mean and the median, but it's asking us to organize. So let's start there so that we have some feel for what it's going to be like. So what's the minimum number of items that someone would pick up in Walmart? And if we just do this by eye, I would say 4. Do we agree? And the maximum number of items that we're picking up?
18.
18. The range will be 14. And how many customers were there?
3.
So this is going to be you forever, right? Always writing this information down so you have some concept of where the numbers are, how many pieces of data. This is a pretty good piece of data because we've got n equals 30, our favorite number here. So how many groups would you suggest? How many classes are you suggesting? 5. So if that were the case and we were going to ask for our class size, we would say this. Approximate equal to 3. So we could do a class size of even numbers. There's one way of doing it. We had 1, 2, 3, 4, 5, 6, 7, 8. Or we could have done it in 3s. If we had done it in 3s, I would have started at 3. Yes? Just on the test, we don't give you the option, we tell you, but just so you have an idea if you're doing your own. So the other would have been 3 to 6, 6 to 9, 9 to 12, 12 to 15.
The test you will ask me the class size?
I will ask all of that, except when it comes to graphic, I will tell you. So I will ask for all of this, and then I will say start at 3 and make your lower limit 3 and the class size of 3.
And if it's a graph, I have to figure out. If it is a graph?
Yes, of course. So in here, we've only got 6. This is a bit better. Yes? So we would have class size. And here, frequency, and I'm going to put them in the calculator because we need to find the mean and standard deviation. So that's edit. Now I'm assuming that everyone knows how to enter data by now. You have all your data in?
Yes, what you did?
Your homework. You just need to check your homework. Did you do it?
No.
Oh, wait. Page 95, number 85. So I'm reviewing and I'm going to move on with the same data. What I want to show you is that whether I choose to do a frequency polygon, a histogram, or something else just means I'm going to write a little different story about it, but it means that I want to be able to show something. So if I do this, I'm going to use, let's see, I'm going to go back, I'm going to graph. My minimum value is 3. My maximum value here is 21. My class sizes are 3 big. And my usual game here is that I put half of it in for Y max. I'm assuming that that probably is not going to be the case. And I'm going to do a histogram, so graph 1. You know, Adam, if we had the smartboard being smart, would it really save all these screens? Does it save screens you project on it, or only screens you write?
I can save project. I can get it to save what you're typing there now if you want.
Like this?
Yeah.
I'm wondering because what they see is only me speaking. They can't.
If you want to finish this problem, just give me a second. I can set it up so it'll save everything you finish.
Shall we try that and see?
Yeah.
Okay, so we have a graph, we have a histogram. We would say that, well, it looks a bit like a positive skew because we have all the values at the beginning and none near the end. And if I wanted to fill in, I would be tracing. And once again, my check, it's plot 1, list 1, and my minimum is 3, my maximum is 6, and I have 6 of them. 6, 7, 9, 6. 6. 1, 1. And what should this total? 30. Okay, I'm going to now, any questions there? That's one way of me displaying the data. I could have decided to display it as a frequency polygon, right, and joined all the dots. I'm also going to find mean and standard deviation, and that's just a straight calculation to add to our story. Very rarely you'll see a research paper that does not include mean and standard deviation.
9.1.
And from our graph, does that make sense?
Yes.
3 to 6, 6 to 9, we're in here somewhere. Our modal class is the tallest one. Remember that we say the modal class is 9 to 12. So we can't be surprised that the mean fits in here. Yeah? This is all sort of clustered together anyway. And the standard deviation, this is just a sample. Walmart is a massive organization with gazillion people in it all the time. If you've ever been into a Walmart store, it sells everything. And the standard deviation for this one is 3.6. So, there are two ways of discussing what we say dispersion. One is to say that the mean of the data is 9.1, give or take 3.6, and I would do that like this. So on average, they should expect that customers buying 9.1 items, even though we know that they can't be 0.1, give or take 3.6.
So you become the 7, which is S6.
It's the X, right?
Why didn't it become the population?
Well, because this is only 30 people. Walmart would be starving. And they're far from starving. So here we could say that we would be surprised if somebody picked up more than 20 items. But again, it didn't tell us what time it was, did it? It said, in the evening hours, okay? So, taking this off, so one way of us showing the data, we would say that 68% of the people buy between 5.5 and 12.7. And is that right? Let's let me sort my data. Stats, sort, list one. Okay. And I'm going to look at the data and see what is 68% of 30. So I'm expecting approximately 20 of my 30 pieces to fall between 5.5 and 12.7. Let's count. Okay, I'm going to start counting at 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 19. And because it's rounded here, I came to 19. And again, what we were saying before is it doesn't matter what our experiment is, what the data we're collecting, they all fall into this normal distribution. And you can see that was very close. The fact that I could have included 13 here.
When did you start at 6?
I started at 3. Oh, why did I start at 6? Oh, here. Right? This is one standard deviation. This is 68%. So I started from here to here. Okay. Questions about all of that? Because there's nothing new going on here.
Can I do the other diagram? Which is the distribution frequency?
The picture? You want me to draw it by hand, you mean, or you want to say it here?
Yeah, like that.
And what was this? Number of items? This is frequency. This is Walmart. And I also need to add evening hours here. That may have something very different to do here than if I was looking at the morning. So. Okay, so we have other ways of displaying this, and chapter 4 talks about other chart ways of displaying. And one of them that we're going to use is the box and whisker. So, and this data happens to be a really good box and whisker candidate, so that's why I'm starting with that one. First of all, can I erase some of this? So, and you understand that I have one way of talking about how the numbers or the items people are buying are dispersed is by using this, by using the standard deviation and the mean. The other way is to do a box and whisker. And when we talk about box and whisker, all we care about is the middle 50% of the people, or in this case, what we're buying. So the box and whisker is always made up of minimum, maximum, the first quarter, and we call it Q1, and the third quarter, Q3, and what's in between these? If I'm dividing something into 4, this is the first quarter, the second quarter will be the center, the middle. So in here, I'm going to have the median. So I could do this by hand. Yes, I could go and count. I could say, well, let's do the median by hand. If I would count down to 15 and 16, correct? I'm looking for halfway of 30 pieces. Okay, so there's 15, there's 16. What do you think the median's going to be?
15.
What will the median be?
9?
9, yes? So, I'm going to put this in here, 9. So I know that I've got 50% on one side, 50% on the other, yeah? Okay, I also want to know the minimum, so I'm going to start putting these values in here. So 4, 5, 6, 7, I'm going to get them all on. Okay, so I'm going to start with first the minimum. The box and whisker is considered to have 5 points only. Min, max, the median, and then the 2 quarters that we're going to find in a second. And the end. So let's get that far done. I'll wait while you draw. So this is just a box with whiskers on the end. So we put the ends on first. And I also know that 9 is my median. Now, I could find the other quarters, but the problem is that this now is at 15 and a half, and to find the quarter then, I really should be dividing that in half again, which would give me 7 and 0.75. So, you don't need to do that, because our calculator doesn't. So let's scroll down. There's our min. Our first quarter, that's 6. What that's telling us is that 25% of the people are in this little arm, this little whisker. Then 25% of the people are from here to here. Yes? And my third quarter, let me scroll down, is 12. So this is a box, and it's called an interquartile range. And the letters that we use to represent that are IQR. And it's important for us to know how big that is. We want to know where 50% of the center people. Here, oh, we erased it. What's this? in this case, we can find the middle 68% by using standard deviation. If we use a box and whisker, we're talking about the middle 50%. So we're saying that 50% of the people bought between 6 and 12 items. So we're just seeing all this is doing is giving us an idea of where the bulk of the people fit. And this does look like this, right? We can already see that we've got a little bit here. This is the cluster that we're seeing, and then the ones that are left over here. If this was symmetric, the whiskers would be the same length. So one of the really good things about the box and whisker is that we don't have to guess. I don't have to say here, I think that this is a positive skew. I can already tell. If the arm in the positive direction is longer, I have a positive skew. So this is a positive skew. Do you understand what I'm saying? Everything is at the beginning, and with a box and whisker, there is no guess. If the whiskers are the same size, it's symmetric. If the box is down my side, then I know that I've got a negative skew. The other thing this does is it tells us if there's an outlier. Because there's a rule. The box, IQR, times 1.5 is the longest whisker I can have. This is a given, 1.5. So in my case, the longest whisker is going to be 1.5 times, and how big is my box? 6, 7, 8, 9, 10, 11, 12. It's 6 long. What is 1.5 times 6? 9? Okay, so what's the if I had 9 here, what's the biggest number I could have? 9 plus 12? 21. If there was anybody that picked up more than 21 items in my list, they would be considered to be an outlier. Remember, we talked about that before. If you include me in your age, then I would be an outlier. And this would show up so easily because we have a rule. So if there was somebody with 22, we would draw the box and whisker, and I'm going to show you, your calculator shows you the outliers. You don't even have to work them out. It shows them. And here, I can't take 9 off, because that would mean I'd have to have somebody returning 3 items, right? Minus 3 would have to be here. So the longest whisker is 9, and then you add on to one end of the box or to the other. Lots to do in one question. Let's first of all let the calculator draw a box and whisker for us. So under stat plot, you see there are 2 of them. There's this one here, the first one, with the little dots that you can see on the screen. That's because they will show you the outlier. That's the one you want to use. Okay, so it will incorporate the 1.5 rule of the box. So we're going to use the first of those. Do I need to wait? Does everybody see what I'm saying? There are 2 box and whiskers. The first one is the box and whisker you want because it will identify the outliers. Okay, and it's already shown up on the screen because my window is big enough to cover it because I've already got the window put together for the histogram. It's here. It doesn't matter your Y value because it has nothing to do with Y at all. And if you trace, it will give you the 5 values. So trace, there's the minimum, there's the first quarter, there's the median, the third quarter, and the max. No outliers here. Questions? It's just a very different way of displaying the exact same data as we did here. And in many cases, this is much easier. If you started playing golf, if I had, or I could even do it with this class, but let's say I took you out to teach you golf. I'm guessing that the bulk of you, the box, when we first took out, would be down here. It would be negatively skewed. You would have a very high score. In golf, you want a small score, yes? And after, say, 3 months of lessons, I do the exact same course again. If I put the two box and whiskers on one axis, I would see the box had moved down. So that would be a way of displaying improvement. If I wanted to show the difference between how men and women play golf, I could do one box and whisker for the men and one box and whisker for the women, and we would see where the box was ending up. It's not any greater than our histogram. It's just a different way of displaying things. But its name to fame is that if you want to eliminate a piece of data, and remember, you have no right. When I start with 30 pieces of data, if I'm going to eliminate one, I must write about it. I cannot not be exhaustive by my own choice. I must say, by the box and whisker, this person buying 22 items is skewing my data and I'm dropping it off. Or I'm leaving it in, I'm just telling you that the data is skewed. Is that okay? Okay, let's look at some of the questions that they have in here. I am on page 113. And I'm going to start at question 15.
Which page?
113. If you plot a box plot, or some software calls it box plot, some call it box and whisker. I like the idea of box and whisker so that when I say the whiskers can't be any longer, you know what I'm talking about. Some software makes them vertical, some makes them horizontal. Our calculator makes them horizontal. The SPSS makes them vertical. Megastats makes them horizontal as well. Megastats makes beautiful ones. If you get Megastats. All right, let's look at the first one. First of all, it says estimate the median amount spent. And the median is always designated by the bar in the box. So in this case, we could guess it to be about 350. This is money spent on books and supplies for students at a 4-year public college. So they're spending $350. That's not the average, that's the median. That means 50% of the people are spending less, 50% of the people are spending more. Estimate the first and third quarters. Well, we could say the first quarter is about 200. This is an estimate, right? I'm reading off a graph that doesn't have a lot of markings on it. And that the third quarter is about 800. So remember, this has nothing to do with mean and standard deviation. That is a whole different story. And then it says, beyond what point? Oh wait, estimate the interquartile range. That means we want to know how big the green box is. In this case, it's 800 minus 200. I'm estimating it to be 600. And if you're unhappy with my estimates, that's fine. Choose. Anyone not understand? The interquartile range is the box. When I multiply that 600 by 1.5, what do I get? 900. So the whiskers in this story cannot be longer than 900. So if I add 900 to my 800, wait, well, how big did you say the box was?
400. 600 divided by 1.5.
Oh wait, I think that I estimated the Q3 bad. Should be about 900, yes? It's more than 800, so it should be about 900.
What?
The first and fifth.
I'm estimating here the Q3, so it should be about 900. And so the interquartile range is about 700. So let's see, what will I get for the longest whisker will be 1.5 times 700, which is equal to 1,050.
Yeah.
We agree? So what's the most amount that we're, yeah, 1.5 times 700. Ask me.
Yes.
The 1.5 is a rule. So the whisker cannot be more than 1.5 times the box. The box in the story I estimated to be 700. I've multiplied it by 1.5, I've got 1,050. So my Q3 plus 1050 is going to give me 1,750. Do we agree? No, 1950. Are there any outliers here? There are none. And I can't take the 1050 off the bottom because I'm only starting at 200. You're looking like I'm speaking some really bizarro language here. Do you not have a clue? Okay, let's move back. First of all, Q1. Q1, what's the beginning? Where does the box begin?
0?
The green box.
300 maybe.
Okay, all right. We can estimate. He's saying 300. Are we happy with that? Okay, where does the box end?
750.
Okay, so we're going to work with these numbers, okay? You always need to start on a box and whisker with the beginning and end. And our next line is, how big is that box? So this box is 450 big. Yeah? So if we want to figure out how long the longest whisker is, the longest whisker we're going to accept, we're going to multiply 450 times 1.5, and that gives us 675.
Rule 1.5.
Always 1.5. It's a rule. It doesn't change with the data. It has nothing to do with it. The whiskers are allowed to be 1.5 long. Anything longer than that, they're gone. So, what is the biggest value, the most amount of money that they can spend on books will be Q3 plus this longest whisker. So for us, it's 750 plus 675. So that's 1425. If there's a number bigger than 1425, it's an outlier. That's the biggest number we're allowed to take. Now, I would also find the smallest number, but can you see? I can't. Because if I did this, Q1 minus 675, I'm going to get a minus number off the chart. So I don't have to worry about there being a smallest number that there is. So what else does it ask us? Identify any outliers and estimate their values. There are none. You see? And is the distribution symmetrical, positive, or negatively skewed?
Negative.
Longest arm is in the positive direction. See, if you look at the picture, the one going up is a lot longer than the one going down. Positively skewed. And if it's in the other direction, it means if it's horizontal, when the longest in the positive direction. Okay, in 16, we have the box plot that shows undergraduate in-state charge per credit hour at four-year public colleges. And What's the estimate? Now estimate the median here.
400.
Okay. It's a little more, isn't it?
450.
Okay. So let me put the values on here. So the median is 450, okay? And the Q1? About 300? And Q3? 7? Okay, and we're estimating, but in most of the ones that you get, there are actual lines, hash marks that will help you not estimate. And how big is our box?
400.
400. What's the longest whisker?
1.5.
So the longest whisker is 600. And that would say, again, I can't take it off here, because that would be minus. So the absolute largest amount, the largest value, or the maximum value I could possibly have will be 700, plus the whisker of 600 will be 1300. So what does it ask us here? It says, beyond what point is the value considered an outlier? So in this particular question, anything that above 1300 is an outlier. Do you see an outlier in this graph?
Yeah.
You see they've marked it with a star. The outlier in this particular graph is 1500. That's the way the calculator will mark it as well. They will show you the outlier. They'll include it in the graph, but they've stopped the whisker at 1300.
So, how you get the largest value?
I add the whisker onto Q3. Q3 was 700,
Yeah.
and we've said the longest whisker is 6. So if you look at this picture on page 113, that is the absolute longest whisker we can have. They stopped it at 13, but there already was a point past that. So that would be considered an outlier. Okay, number 18. A sample of 28 time shares in the Orlando, Florida area revealed the following data. Charges for a 1-bedroom suite. For convenience, the data are ordered from smallest to largest. Construct a box plot to represent the data. Comment on the distribution. Be sure to identify the first and third quaternions and the median. So you can do it by hand. How many do we have? 28. So we could cut it at half at 14. That would be the median. And then the ones we have left, we could cut again, or we could put it in the calculator. I'm going to put it in the calculator. I'm going to put it in list 2.
So can you just click on the tab that says large screen? Right there.
That doesn't make a large screen, does it?
But it lets them see instead of the keystrokes.
Can I do it from over here as well?
No.
Yeah. Which do we want?
Not like that.
Hmm?
Not like that.
Okay.
We can't see the calculator now.
So I want the size, medium.
And just
I see.
yeah.
All right, I'm putting this into 2. Clear. Okay, and I'm going to put all this data in. This is continuous data. It's money. Okay, so I have all the pieces in, but I've made a mistake. How do I know? How do I know I've made a mistake here?
28.
Because I'm finished and I've only got 27 pieces of data. So I need to look. It's right there. And remember, I insert by putting blue, because I want to put it back into here. No, I don't. For the calculator to do my box and whisker, I don't need it in line. It doesn't have to be sorted. It wouldn't have made any difference. It will do it anyhow. So, first of all, I'm going to fix my window. And I know that my minimum value is 116 and my largest is 353. So here I would say 100, just because I don't want the box and whisker to be cramped from wall to wall. And I'll go to 400. So that will probably be groups of, say, 20. And that other one doesn't matter. And I'm asking it to do 1, but wait, I put it in 2.
Miss Sarah, you put the mine 100 and the max?
400. I could have done exactly 116 to 253, but then my box and whiskers hands are right at the edge of my screen. That's just a personal choice. It doesn't matter.
And what about the X?
Doesn't matter. Why doesn't matter? It doesn't matter what you put on there. It's going to be at the top of your screen. There are no Y values, right? How big you make the box this way makes no. Never mind. What kind of skew is this? Negatively skewed. The whisker in the negative direction is longer than the one in the positive direction. And construct a box and whisker, comment on the distribution. Any outliers? None. And we would say if we were writing an article for a paper, we could say that 50% of the one-bedroom condos or whatever they are can be found to be rented at, and let's see, between $219 and $301. So the ad would read something like, 50%, you can get between $220 and $300. That's very different, and that's, it's your choice as a marketer or a business person how you're going to do this. You can decide. This is a great way of displaying it. I really like these. They're the only method that we're going to use for outliers. So if in the data, I think that I asked if there were any outliers in your assignment. No. But on the test there will be. There will be box and whisker and ask to find the outliers. Exact same questions that are in here. Questions? Is this goodbye?
Yeah.